All right, folks, welcome back. We are actually going to be talking about side splitter theorem today. Basically, everything about today's lesson is based on parallel lines, and they make ratios when they're hit by transversals, and those ratios will be equal. So let's go ahead and take a look at a few proportions we could be making here. So here we've got four parallel lines. And we've got two different transversals, and I've labeled them with QRS, TU, and V. And what's going to happen here is if I take a look at what R corresponds with, I'm being shown by this proportion that R will correspond to U, which I can see those are the kind of like middle level. So then what value on the bottom left would correspond to T? So when I look up at the diagram, T would be corresponding to Q. So the ratio R over Q would equal U over T. I'm going to go ahead and walk through the rest of these. If S corresponds to V, what will correspond to T? Well, again, that would be Q. So I actually have the same answer on the first ones here. So Q divided by S would equal T divided by V. Now, T corresponds to Q, as we've already well established. So if T corresponds to Q, V would have to correspond to S. And that's how these work. Now there is a different approach here for the last two. So let's stay tuned in. Here we're going to say, all right, Q corresponds to S. So then what does T correspond to? Well, since it went Q corresponds to S, we're going to say T corresponds to V. Now you could also look at it as Q to T, Q over T is equal to S over V. Now on the last one, S over V, S V would have to equal R over U. So you can see we just kind of changed it up on these last two, where these were going across from each other. When you looked at the numerators, here the numerators are actually on the same side, but if you look at the ratio, you're still going to get a hint on where to go. So that's going to be this first set of problems, just a quick identification of what value you're looking for there. Now, on the second group of problems, you're actually going to be solving for x, like we normally do here. And what you're going to encounter here is these two problems, actually. I'm going to go over two of the problems from the assignment. So let's go ahead and take a look at this first one and see how side splitter theorem could actually get used. On the first one that I'm looking at here, you're going to say, well, there's not a third parallel line. Well, there's not, but these two transversals do intersect, so the proportions do hold true. So if I make the ratio, for instance, x over 12, that would have to equal the ratio x would correspond to x plus 1, and 12 would correspond to 15. And that would be my setup. Now I am going to go ahead and walk this through really quick, but I'm going to go pretty quick with it. So 15 is going to multiply x, and 12 is going to multiply x plus 1. I'm going to distribute the 12, so 12x plus 12 is what I get there. I'm going to subtract 12x from both sides, so 3x equals 12, and divide by 3, x will equal 4. That's my answer. Now, that's one setup I could have used. Another setup would have been x over x plus 1 equals 12 over 15. If you do that, it's going to work out the same way. Just your first step would look different. Just to show it really quick, x over x plus 1 equals 12 over 15. If I do cross multiply that, the 15 is still multiplying x. So 15x, the 12 is still multiplying x plus 1. So really, you're right back into the same process in that situation. So on this last problem I'm going to talk about, there's two substantially different setups you could do. I prefer one over the other, but I'm going to show both setups just to validate that they are there. So one of the things I haven't really talked about is adding together the two values when you're making the ratio. So for instance, if I do x over 20 the whole side, so x over 20, well, x would clearly correspond with the 12, so 12 right here, over, but the 20 would actually correspond with the 16. All right, so now that you've seen that, uh, let's go ahead and talk about what the other setup could have been. And then I'm going to come back and do this one because that's really what I'd prefer to do here. The other setup could have been where you actually do 20 minus x to describe this value right here. And then you make the proportion x over 20 minus x equals 12 over 4. And then you're set and ready to go. Now, I think that's going to be more work to do. That's the reason why I prefer the original one. So really, I don't even bother with that step right there usually. Does kind of depend on the situation though. I did want to just clarify this is also very legitimate to do right here. All right, going back up here, I'm going to multiply 16 and x. I'm also going to multiply 20 and 12. And then what I'm going to do is go ahead and solve this. So 16x will equal 240. And I'm just going to divide 240 by 16. And I result with x equals 15 on this problem. Same answer had I done it the other way. All right, folks, that's a wrap for this video. Hopefully you find this pretty easy to do. Tomorrow we'll be moving on to applications. Thank y'all.